Next topic is design a DFA for the language L is equal to A power n B, where n greater than or equals to 0, where sigma is nothing but a comma B. So here you need to design a DFA for the language L is equal to A power n B. In these cases you need to consider that n is greater than or equals to 0, which means that you start with n is equal 0. So a power 0 b. If n is equal to 1, a power 1 b. If n is equal to a power 2 b, and so on. So the language is having the set of strings like this. A power 0. A power 0 means 0 times a. 0 times a means epsilon. Okay, epsilon means nothing, which means that you can consider only b. A power 1 means a power 1 means a can be written one time, and b. A power 2 means a can be written twice, and b, and so on. This means that it should acceptable whenever it ends with b and starts with any number of a's. So here by seeing this acceptable strings, you can come to know that the string is, if input symbols are ending with b, then it should be acceptable. So here I am starting with initial state, and if 1b also comes, it should be go to the final state. So first always you need to consider the initial input string. Initial input string is only 1b. If 1b comes, it should be go to the final state, and before the b, if any number of a's comes also, if n is equal 3 means 3 a's 1b. So ending with b, and before the b, if any number of a's comes, it should be acceptable. Okay, this is the case. Now you need to check, this is nothing but a deterministic finite automata. In the deterministic finite automata, you need to check that whether each and every state is having the all the set of input symbols or not. So at the state q naught, a and b, here sigma has mentioned that the set of input symbols a comma b. So q naught followed a comma b, q1 should follow a comma b. For example, if I have written b here, what will happen? If I have written b here, then for example b I have written self loop, means what will happen? A 1b a b b also accepting, or if input symbol is b, b b is also accepting. But in the language he mentioned that a power n b only acceptable, which means that this type of strings only 1b or 1a 1b, any number of a's ending with only 1b only. But here ending with 2b is also accepting if you mention the self loop. So in such cases, if you mention for example back like this, you mention, then what will happen? So here a b b b, it should not acceptable, only ending with 1b only acceptable. But if you have taken self instead of self loop, for example you have taken back, then what will happen? Q naught on a, q naught start with initial state. So q naught on a, it is going to the state q naught only. Q naught on b, it is going to the state q1. Again q1 on b, for example if you have given q naught state, and q naught on b, it is going to the q1. After reading the entire input symbol, it is going to the final state. But this input string should not be acceptable your DFA. Why? Because you are designing DFA for a power n b. So you cannot give the input b here also, and you cannot give input b here also. So in these cases what you can mention means, you can mention one dead state. Okay, q2 state you can mention. And on the q2 state, if q1 on input a or input b appears, it is going to the state q2, and q2 is nothing but a dead state. And for the q2 also, input symbols a comma b you can mention. So if you mention the input, whenever a power n b appears, then it should go to the final state. Whenever more than b appears, obviously it will go to some dead state. It should not be acceptable by DFA. So this is the DFA for accepting a power n b. After designing DFA, for every DFA you need to mention the 5 tuple notation. That 5 tuple notation are q. First is q. Q is nothing but a here set of states you need to mention, q0, q1, q2. Next you need to mention the sigma, what input symbols you are going to be considering, a comma b. Next you need to write the transition function. So transition function of q0 on a, where it is going, q0. Next, transition function of q0 on b, where it is going, q1. Next, transition function of q1 on a, it is going to the state q2. q1 on b also it is going to the state q2. q2 on a it is going to the state q2. q2 on b it is going to the state q2. After mentioning the transition function, you need to write the initial state. What is the initial state? q0 is nothing but a q0 only. And you need to mention the final state. Final state is nothing but a q1. And it's better to take one input string, any input string which is acceptable by finite automata. For example, AAB is acceptable by a power n b. So I am considering any input string, and you need to check whether this input string is acceptable by this DFA or not. So here I have taken AAB. So transition function of always input string starts with initial state. So q0 and your input string you need to mention. So q0 on a, q0 on a, where it is going, q0 only. So you take the q0, and next state is q0. So q0 and next input symbol is a. So q0 on a, again q0 on q0 on a, where it is going, q0. Next, transition function of next state is, this is the present state. Okay, this you need to consider. q0, this a is already read. So q, next input symbol will be b. q0 on b, q0 on b, q0 on b, where it is going, q1. So this one is also read. After reading the entire input symbol, if DFA reaches to the final state, here if you observe, q1 is the final state. So after reading the entire input symbol, if DFA reaches the final state, okay, reaches final state, then the input string is acceptable. Okay, this is a simple example for designing a DFA for the language L is equal to a power n b. This is important only.